Hello students, today we are going to see some important questions from glucose. Glucose is also known as D-glucose, that is dextrose. This is generally we can say grape sugar. Okay, now come on, let us go for the formula C6H12O6. Okay, formula if we know, functional group also we should come to know. So functional group, it is a aldehyde, we can say hexose. So aldohexose means the general formula molecule, it is CHOH 4 times, here CH2OH. Okay, now through this we can identify it has that aldehyde group and it is having 6 carbon. Through some reactions we can make out. So that is like a proving method. Okay, now here glucose reacts with reducing agent such as hydrogen iodide. So that is hydroiodic acid in the presence of red phosphorus. The glucose is reduced to N-hexane. What do we call? N-hexane. CH3, CH2, 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 CH3. 1, 2, 3, 4, 5, 6. N-hexane. So it is a straight chain and 6 carbon. So we can make out that glucose is having 6 carbon. Okay, now next one, aldehyde group it is there, no? So let us go and see another one more question. That means another one more reaction here. HCN, hydrogen cyanide. So glucose reacts with the hydrogen cyanide. You are getting glucose cyanohydrate. That means CH, here OH and here CN. Here CH, OH, 4 times CH2OH. So what do we call here? This is glucose cyanohydrin. Cyanohydrin. Okay, now next one. The same way this reacts, glucose reacts with hydroxylamine NH2OH. We have learnt in that what it is, amine compounds, no? So that hydroxylamine. So here what happened? Removal of water it is taking place. So here removal of water, this H2 and this O combined with together, it is H2O removal. So that means what is the product you will get it? CH double bond NOH and CHOH. Same as it is 4 times CH2OH. So what do we call this? This is glucose monooxide. Monooxide. Okay, now through that we can make out what it is. Aldehyde group it is present. Okay, next one more. Mild oxidizing agent. Okay, mild oxidizing agent we can take bromine water. So bromine water if we take, we can get gluconic acid. So usually, generally what it is, aldehyde converted into acidic group. Acid group only no through mild oxidizing agent. So here CHO converted into COOH. Right. Then CHOH 4 times CH2OH. So what do we call this? Gluconic acid. Gluconic acid. Okay, now one more thing. Is it visible? Yes. Now the next reaction, glucose reacts with concentrated nitric acid, HNO3, concentrated. Okay, so glucose reacts with concentrated nitric acid. You will get saccharic acid, saccharide, no, so that we can say saccharic acid. So what it is? COOH, here CHOH 4 times COOH. So what we can say? Saccharic acid. Saccharic acid. Okay, now next one. Actually, glucose is having 5 hydroxyl group. So how to identify it is having 5 hydroxyl group? This is CHOH 4 times OH. So, what is the product we will get it? Suppose if it reacts with acetic anhydride. What, you know what it is acetic anhydride? CH3CO twice O. So, acetic anhydride reacts with glucose. You are getting glucose pentacetate. So, what is the product here? CHO, it will be same as it is. Aldehyde group will be same as it is. We are proving what it is. 5 hydroxyl group only it is available. So removal of hydrogen in that acetate will be attached over there. So that is CHO, CO, CH3. 4 times. Here CH2. Yes, CH2O, CO, CH3. Okay, so what is the name we can say? This is glucose pentacetate. Okay, hope you're clear with this. So we can make out glucose is having aldehyde group and 5 hydroxyl group also it is available. And one more thing, glucose it is a neutral when it is reacts with water. So when it is hydrolyzes, glucose hydrolyzes automatically, you are getting a neutral solution. So neutral solution means absent, glucose is having that absence of a carboxylic acid. So it does not have carboxylic acid group. Okay, only it is having what it is, aldehyde group. Okay, we'll see some more points to be noted from the glucose. Hope you're clear whatever we have gone through so long. The next point, it is D-glucose. How do we name it is a D-glucose? Okay, D and L system. First and foremost, we will come to know how to name that. D and L system naming a compound, it is so simple. That D and L system naming a compound, it is based on the position of the substituent group on the asymmetric carbon atom. Okay, now I'll give a small example so that easily you can come to know what it is D and L. Okay, now CHO, CHOH, and here CH2OH. Now, I just take the glyceraldehyde example. Glyceraldehyde, that OH group. Now, this carbon, it is an asymmetric carbon. That OH group, which is present on the right hand side. So, we can say D-glyceraldehyde. Glyceraldehyde. Okay, the same way the carbon CHO, this OH which is connected with the left hand side, CH2OH. So this OH which is connected with that left hand side. So this is L-glyceraldehyde. Okay, L. Now I think you come to know D and L. D means nothing. Dextro, it is a right hand. Right. Okay. So here D glyceraldehyde, L glyceraldehyde. I hope you got a clear idea about what it is D and L. That is naming a compound based on the position of the substituent group. Hope you're clear. Okay, let us go for the D glucose. Here CHO group it is available. Here carbon which is connected, this CHO group which is connected with 5 carbon, that is aldo pentose also we can say 1, 2, 3, 4, 5 and 6 CH2OH. Now here H, OH, here OH, H, here H, OH and here H, OH. So this is a D-glucose we can say. Now this generally, which is the highest asymmetric carbon atom. So that means here 1, 2, 3, 4, 5. So fifth carbon it is having the highest asymmetric carbon atom. So fifth carbon it is OH group which is present on the right hand side. So we can say it is a D-glucose. Hope you're clear with it. Why do we say it's a D-glucose? Because in that asymmetric, how many asymmetric carbon is available? Here 5. 1, 2, 3, 4, 5. 5 carbon atom maximum, which is the highest asymmetric carbon atom. From that only we can give the name. So in the fifth carbon OH group which is present on the right hand side. So we can say it is a D-glucose. Okay, next one more point we are going to see cyclic structure of glucose. Hope you're clear with these points. Let us go for the another one. The next point actually very interesting. Aldehyde group which is present in the glucose. Through that, what we have found that is through tolerance reagent, Fehling solution, and Benedict reagent. Through that, we found that is actually aldohexose. We found that, but it is answers only for tolerance reagent, Fehling solution, and Benedict reagent. Only it is answer. But actually, aldehyde group means all the confirmation of aldehyde confirmation test it has to answer. But it does not, glucose does not answer for Skiff's reagent and sodium bisulfite mainly. And react with the RMGX, that is Grignard reagent. Pentacetate of glucose do not react with hydroxylamine. And these are all not answering, though it is having aldehyde group. Why? Actually, it is really typical question and give reason that question. Why it does not react with Skiff's reagent? Why it does not react with sodium bisulfite? Definitely you may get such kind of question. Actually, for this question only, you are getting a new point, anomers of glucose. Generally, glucose in the crystalline form of glucose, actually two forms it has exist. It is actually alpha glucose and beta glucose. Alpha glucose melting point, it is crystalline form, it is actually 419 Kelvin. The same way beta glucose, it is 423 Kelvin. It is in melting point, but it in boiling point it is 303 Kelvin. It is in solution state. The same way 371 Kelvin in that solution state. These are all boiling point. Okay, so the next one what we are going to see, anomers of glucose. For that we have to write the structural formula of glucose, CHO, and 1, 2, 3, 4, 5, and 6 CH2OH. Then here H, OH, and here OH, H, and here H, OH, and here H, OH. See, fifth carbon, this is fifth carbon. Now, fifth carbon OH should be right hand side. You please remember in that way. 1, 2, 3, 4, 5, and then this is 6. Okay, and small rearrangement here. See, double bond OH, CHO only. Now, what happened? This anomalous carbon formation here actually, here this OH group of the fifth carbon, which is going to attack the carbonyl group of the first carbon. So, what happened here? Hemiacetal formation takes place. Hemiacetal formation. So hemiacetal formation takes place means the CHO group converted into CHOH and form a ring structure of 6 carbon. Okay, now what happened here? Carbon 1, 2, 3, 4, 5, and 6th carbon CH2OH. Now here what happened? This CHO, no, this O which is combined with that hydrogen, you will get what it is? OH formation. CHO converted into CHOH, and the same others and all as it is CHOH, and here OH, H, and here H, here OH, and fifth carbon H. This O which is going to join as a ring structure to form the, here what it is, joining over here the first carbon. This is first carbon, 1, 2, 3, 4, 5, and 6. Okay, so this is what it is, alpha D plus glucose. So, why I mentioned alpha D glucose means here OH group which is present on the right hand side. Now, here what happened, the same way first carbon which is attached, that OH group which is attached with the left hand side, CHOH, the same structure only. The only thing what it is, OH group will be left hand side, OH group will be right hand side. So, this is beta D glucose. Okay. Now, here what it is, C, here OH, here H, and then here what it is, C, third carbon, C, here OH, H, here C, H, OH, and then is it visible? Yeah, here fifth carbon, 1, 2, 3, 4, fifth carbon hydrogen, here this only which is going to attach with this. Okay, and then sixth carbon CH2OH. Is it visible? Yeah. Okay, so this is what do we say? Beta D plus glucose. Okay, now beta here also D we mentioned the fifth carbon only which is going to change. So that is the reason we mentioned D, and here alpha D glucose and beta D glucose. Hope you are clear with that idea. Why do we get such kind of formation? Okay, now the main difference of two forms, which is carbon 1 OH group present on the right hand side, whereas here carbon 1 OH group present on the left hand side. So this carbon 1 is called anomeric center. Okay, now anomers is nothing. This carbohydrates, these both are carbohydrates, are obtained by changing the position of OH, is called anomers. So this is that anomers of alpha and beta glucose. Alpha glucose is a anomer of beta glucose. Actually, this ring structure, it is called Fisher's ring structures. Okay, hope you're clear with that. What is that hemiacetal formation? How do we get this ring structure? And what is it anomeric center? What are all called anomers? I hope you're clear with that. Okay, now next class we are going to see some most important questions. Most important questions we are going to see. Hope you're clear with it. Thanks for watching.